we will see how beautifully the two techniques brings out the analysis part of stability determination of a given system in when it is represented in frequency domain. Very interesting techniques developed and presented by these two scientists, Bode and Nyquist. Later on, 30 years from that, in 1948, Walter R. Evans, while working at aircraft industry in Boeing plant, again in USA, developed a graphical technique to plot the roots of characteristic equation of a feedback system. He continued the work of Bode and Nyquist and of a feedback system. And here now he extended a new graphical technique whereby you can obtain a loci of roots that would be generated by varying a given parameter of a system. And this technique is today called as root locus technique. So this technique allows us to analyze system stability, its behavior in time domain, whereas earlier two techniques of Bode and Nyquist allow us to study the system performance in frequency domain. So these three techniques would be forming the backbone chunk of our course would be dedicated towards these three techniques, which forms very strong foundation in system stability and analysis. So you all should wait patiently for this to be presented in while we progress in the course. Then in contemporary applications, we see control system today finds place in host of applications from guidance, navigation, controls of missiles, aircrafts and ships, in process industries, in chemical plants, in manufacturing industries. There are a host of control systems which are at work for allowing automation and increasing the overall production efficiency in industries. Along with that, I have mentioned here the number of control systems that are made into a space shuttle for its efficient and successful space missions. So there are flight control systems, orbital maneuvering systems. All of this is automated and controlled with very few things left for the crew and the man who will be guiding the mission. So we have different control surfaces like aero surfaces when the spacecraft is inside the Earth atmosphere. So from ground station, the aero surfaces are controlled to steer the shuttle. But once it is outside the atmosphere of Earth, then no more aero surfaces have any impact on the on steering the flight. Then there are numerous small jet engines which are used to navigate and guide the spacecraft. Then there are multiple control systems for efficient utilization of fuel, both for electricity and for water, and keeping the oxygen level sufficient inside the space shuttle for the cabin crew. So we will see some of this in the form of a videos that I have selected for you guys. Hope all this is interesting for you.